Hey there, grade 10 math students. We are at the last lesson, I guess, in the quadratics unit, which is exciting. So I'm just going to go into presentation mode. We're going to do a review today of the unit. There's no specific handout for this, so it would be good for you to take notes with this in your own words, in your own writing, so that way you're more than likely to remember it. Once we're done this, there will be no quiz or quizzes this week. What you'll need to do is an assignment for this unit. Okay, so let's remember what we did. So first we talked about the difference between linear and quadratic relationships. So a linear relation forms a graph with a straight line. And we spent lots of time in this course working with linear relations. So just remember linear has the word line in it, and so it has a straight line. A quadratic relation forms a graph that has the shape of a parabola. So that's one way you can tell the difference between linear and quadratic is by looking at the graph. The next way is to look at a table of values and look at the first differences and second differences. So let's take a look at this table. So we have our x values are 0, 1, 2, 3, 4, and our y values are 2, 3, 6, 11, 18. So we're going to find our first differences from doing the bottom one minus the one above it. So 3 minus 2 is 1, 6 minus 3 is 3, 11 minus 6 is 5, and 18 minus 11 is 7. Now, if this was a linear relation, it would be graphing a straight line, so first differences would be the same. So first differences aren't the same, so it's not linear. So let's see if the second differences are the same. So if we do 3 minus 1, that gives us 2. 5 minus 3 also gives us 2, and 7 minus 5 gives us 2 again. So notice how the second differences are the same. So this relation is quadratic because the second differences are the same. The third way, which I'm not going to really discuss here, to just determine if it's linear or quadratic, remember linear equations have an x term in it, and a quadratic equation has an x squared term in it. Okay, so just to summarize that, a linear relation has the first differences equal, and if you went to the second differences, they would be equal to 0. A quadratic relation has the second differences equal. So those are some ways you can tell the difference between linear and quadratic. You will see this kind of material in whichever grade 11 course you take. So it's really good to understand this stuff now, just how to tell the difference between the two. Okay, the next thing we did was we looked at graphing. Um, so there are basically two different ways graphs can be drawn, and these are examples. So a quadratic relation can be seen when a ball is thrown in the air and the height is measured versus time. A sketch of this might look like a parabola going like this. And I'm going to read through this first and then we're going to fill this in. The second one, a way it can be drawn is a quadratic relation can be seen when a duck flies into the water, catches a fish, and flies back out. So it's going to start high, go down low, and then come back up. Okay, so in the first one, the ball, it's going to start low, go up high, reach a maximum height, change direction, and come back down. So remember, this parabola is facing downward, and the vertex is the highest point of the parabola, so it's called a maximum. If we have this duck, it starts up high, it swoops down into the water, and then goes back up. This is an upward facing parabola, And you can see the vertex here is the lowest point of the parabola, so it has a minimum value. We also labeled some key features of quadratic graphs. So if we have this quadratic graph, here are the key features that we really looked at. So the vertex, remember, is the um, point of the graph that's either the lowest in this case, or if it's facing the other way, the highest. I like to think of it as the point where the graph starts changing direction as well. So that's the vertex. The axis of symmetry is the vertical line that goes through the vertex. Okay. And something that's not labeled on here is the maximum or minimum value. Remember, the maximum or minimum value is the y value of the vertex. The zeros are where the parabola goes through the x-axis, or those are called the x-intercept. And then the y-intercept is where the graph goes through the y-axis. So those are the key features that we were looking at, and you will also see those in any grade 11 class that you do next. Okay, what else did we do? Well, we looked at different forms of quadratics. So if we look at standard form, and I guess I should put that, let's put standard form here. So standard form is y equals x squared plus, oh sorry, ax squared plus bx plus c. And I'm just going to make this into a superscript, sorry. Okay. So, from standard form, you can get the y-intercept from the last term or c term. We can change factored form into standard form by expanding factored form. And there are three methods of expanding. Algebra tiles, the table method, which I didn't show you before, or maybe I did, I don't remember, but I'm going to go over it again, and then using FOIL. And I'm just going to copy that. So standard form, I'm going to paste it here. Okay. So I'm going to go through an example with how we expanded um, relationships. But the first one, let's just do an example of just expansion. So remember, if we expanded something like this, y equals 2x times 3x minus 4, well, remember, when you're expanding, you're going to multiply this term in front of the brackets to every term inside the brackets. So y equals 2x times 3x minus 4 becomes 2x times 3x plus 2x times negative 4. And now this term, you're going to multiply the two numbers first, which is 6, and then multiply the x's, which becomes x squared. And then here, 2 times negative 4 is negative 8, and then we have an x. So this becomes 6x squared minus 8x. So that's how we expanded something like this. So now we're going to take a look at expanding a equation in factored quadratic form. So we've done this using tiles. I'm going to show you this table method, although I may have done this, so I'm going to go over it, and then I'm going to go over FOIL. And then it's asking us, what's the y-intercept and the x-intercept? Okay. So first by tiles, if you remember, if you have x plus 4, you're going to fill in, this is going to be an x, and then you're going to fill in with 4 red ones because the reds are positive. And then on this side, you're going to do the second binomial. So this is going to be your x term, and then we have negative 5, so it's blue. So 1, 2, 3, 4, 5. And then to figure out what your answer is, you're just going to count up how many tiles of each type you have. So remember, the big squares are the x squared tiles, and we have one of those, so 1x squared. Now, if we count up the x tiles, those are the rectangles, we have 1, 2, 3, 4 positives, but we have 1, 2, 3, 4, 5 negatives. So -5 plus +4 gives us -1x. And then we're going to figure out how many of these single tiles we have. Well, we have 1, 2, 3, 4 in each row, and 1, 2, 3, 4, 5 rows of 4. So that's -20. So if we expand it, it becomes x squared minus x minus 20. The table method is exactly the same way, you're just not using tiles. So you're going to place your first binomial in the top two squares, so x plus 4, and then your other binomial along the left side, x minus 5. And then each box is the multiplication of the two terms that intersect there. So this box, x times x, is x squared. Now that I'm talking about this, I'm pretty sure I did this, but just to go over the rest, this one is 4 times x, which is 4x. This one is -5 times x, so -5x. And this bottom box is -5 times +4, which is -20. And now you write these down. We take the x squared term first. Then we can combine our x terms. So -5x plus 4x is -x. And then we put our last term down. So x squared minus x minus 20. Excellent. And then the third method is FOIL. So remember, FOIL stands for first, outer, inner, last. So our first terms are x times x, which gives us x squared. Our outer terms are x times -5, so that's -5x. The inner terms are 4 times x, which is 4x. And our last terms is 4 times -5, which is -20. Now we can combine these x terms to reduce it to x squared minus x minus 20, which is exactly the same thing. Now, if you remember from this form, the standard form, the y-intercept is -20. It's the last number in standard form. And the x-intercepts are the numbers in your factored form, but we take the opposite sign. Okay, because to make this binomial 0, x has to be -4. That's why they're called zeros as well. In this one, x would have to be 5 to make this bracket 0. So that's why those are the x-intercepts. They're also called the zeros. Okay, so we've done expansion. Now, don't forget, we also did the other thing, going backwards, which is factoring. The first thing we did was common factoring. Just to review, factored form looks something like this: x minus r times x minus s. And I think I've been using s and t. It doesn't matter what these letters are, it just follows this kind of pattern. So for example, here, let's say we have y equals x squared plus 3x, and it's asking us to state the x-intercepts. Well, remember when we have terms like this, you're going to see if there's a greatest common factor that can come out of each term. So now notice how we can take an x out of this one, as well as an x out of this one. So if we take an x out of both, we're going to be left with x plus 3. Because if we divide x squared by x, we get x. And if we divide 3x by x, we're left with 3. Now, you might be wondering, this doesn't look quite like this, does it? We have 1 in that form, but this one's just hanging out by itself. Well, if you get something like this, just know this can be written as x plus 0, or x minus 0, if you want to think of it that way, and x plus 3. So our x-intercepts would have to be 0 and -3. Okay. So remember, trinomial factoring. This is where we go from standard form, ax squared plus bx plus c, to factored form. So if we remember how we do that, here's an example. So if we have x squared plus 3x plus 2, the goal, we did this using tiles at one point. So what we do is we're going to go backwards. So now you're going to fill in down here first and then see what you have left on the outside. So we have one x squared tile and we have three x tiles. So you could fill it these two and then here. You could draw all three here, but remember, you have to make a rectangle. And if it's not a rectangle, you can't factor it. So you have to set it up like this in order to use the right number of tiles that you're told to use here. So we've got one x squared tile, three x tiles, and then two single tiles. So now you figure out what you have at the top and what you have at the bottom. So on the top, you have an x tile plus 2. So that's one of our factors. And on the side, we have an x tile plus 1. So that means to factor this, it becomes x plus 2 times x plus 1. So that's one way we can do it. The other way we did it was using the x's and oh yeahs. This is using algebra. And I'm hopeful that after doing that pattern several times, you'll realize what you were doing is you were finding two numbers to give two numbers that multiply to give this last number and add to give the middle number. So what's two numbers that can multiply to get to 2, but also add to get to 3? So 1 and 2 will do this because if I do 1 times 2, I get 2. But if I do 1 plus 2, I'm just going to change that to an ampersand. So it's a little more clear. So 1 and 2 works. So that means to factor this, once you have those two numbers, remember when we did x's and oh yeahs, you just put those numbers into our standard form, or sorry, into our factored form with the signs that you found. So y equals x plus 2 times x plus 1. Now taking this a little further, I forgot to do this. So we're going to animate this by paragraph so I can show it to you step by step. So to fully factor something means you also need to take out any greatest common factor and then factor the trinomial. So to fully factor this, our first step is to take out the greatest common factor. Well, we can't take out a greatest common factor of x because this guy doesn't have an x. But we certainly can take out a number that goes into 2, 2, and 60, and that would be 2. So if we divide each of these terms out by 2, you're going to take that 2 in the front, and 2 divided by 2 is 1, so it's x squared, and negative 2 divided by 2 is negative 1, so negative x, and then negative 60 divided by 2 is negative 30. Now we have this form, we can factor this trinomial by finding two numbers that multiply to give negative 30 and add to give negative 1. So negative 6 and positive 5 will do this, right? Because negative 6 times positive 5 gives negative 30, and if we add those, we get negative 1. So now you're going to put those two numbers into our binomial equations. So don't forget to bring this 2 down. So 2 times x minus 6 times x plus 5. We also did some word problems with this, which is kind of difficult to review because what we did with the word problems was just take all the information we just talked about and applied it in a word problem situation. So your task for this week, no quizzes. There's going to be a Unit 4 assignment posted on Brightspace. You can hand this in whichever way you would like. If you would like to try to fill it out electronically, You can do that and then submit it back through Brightspace. If you would rather print it out and write your answers and take photos or scan it in and send it back through Brightspace, you can do that. If you want to do it on a whiteboard or a piece of paper, scrap paper or something like that, and then take pictures of it, you can do that. And I want you, though, to show your work. I've been getting some assignments back in where you're either just giving me the answers or showing very little steps. And I understand it can be difficult if you're trying to type it. So do your best to show me your thinking so I know that you understand what you're doing. Okay, that's it for the lesson for this week. And the rest of the week, you'll be working on this assignment. And please have it handed in by midnight of Sunday. All right, guys, chat to you next time. We'll be splitting again into two different units for the two P's and the two D's. So keep an eye out and see you next time. Bye bye.